Hello folks, we come to the part 1 video of this exercise 1.2, and here now we are starting with functions. Function is nothing new to us. We had learned it in the last year. We learned that relations, last year we learned relations, functions, but this year we learned types of relations, like it is what is reflexive, what is symmetric, what is transitive, and then its equivalence relation. So also this year we learned types of function, injective function and surjective function. Injective is also called as one-to-one and surjective is called as on-to. The meaning of injective function is that the meaning of injective function is every function will be, every point on the domain will be related to a single image. This is the meaning of one-to-one functions. And onto function is that every point on the codomain will have some pre-image. It will always have a pre-image. That is the meaning of onto function. You will not have any unrelated elements here. So if at all it is like this, then it's not onto. Okay, there will be no unrelated. Every element that is there in the codomain will have a pre-image. That is the meaning. So we will see now how to show it and how it is going to be like. So first you have to show that f is 1-to-1. So 1-to-1. So there is a way of writing it. Let f of x1 be equal to f of x2. By definition, f of x is 1 by x, so f of x1 will be 1 by x1. F of x2 will be 1 by x2. We can have it like interchange. So you have x2 equal to x1. We'll have x1 equal to x2. Thus, f of x1 equal to f of x2 will imply that x1 equal to x2. Therefore, f is 1-to-1. Right? So the function is 1-to-1. It's been given to us. Now we'll go to the onto part to show how it is onto. Now, in order to show that it is onto, we'll start with an element in the codomain set. Let some y belong to the codomain set. Let y, it's like this. Yeah, we are starting with a y in the codomain. Let y belong to the R0, which is codomain, because both are the same set. We have to specify that's from the codomain. Where should it be related? For example, if I have a phi here, from where there should be a function by which we are getting the phi, right? So where it should be coming from? It should be coming from 1 by phi. Why? Because f of 1 by phi, you just check how is the definition. F of 1 by phi by definition will become the reciprocal, because the function is make it the reciprocal. So it will become phi. That's how it is coming. So we'll understand that logic and we'll say that for y belonging to the codomain, there exists 1 by y belonging to R0 domain, such that f of 1 by y equal to y. So you give me any element, I can tell you from where it is coming. Like you tell me 10,000, it will come from 1 by 10,000. So you take any element from here, you should know which is its pre-image. That is the meaning of onto. So it is onto. Therefore, f is onto. Let's see what the question says. Question says that show that it is 1-to-1 and onto, that we have shown. Is the result true if the domain is replaced by n and codomain is R0? Suppose say if f becomes from n to R0, whether this will be true is a question. For 1-to-1ness it won't be a problem. For 1-to-1ness it should be okay, it will hold true, same logic, it will come true, but onto will not be correct. Why? Because suppose if I take any like 5 for example, then the pre-image is 1 by 5. 1 by 5 is not belong to natural numbers, isn't it? So we'll have it. In this case, f is still 1-to-1 and working is exactly identical, but not onto. Now why it is not onto? Since phi belonging to R0, for phi belonging to R0, there does not exist any element in n such that any element maybe x, f of x equal to 5, means the one that should be existing, it should have been 1 by 5, but that 1 by 5 is not there in natural number. That is why we say there is no existing element in n that can go to 5, right? So that is why it doesn't hold. That is our question number 1. Now in the question number 2, they say that show the injectivity and surjectivity. Check. You don't know whether it is, you have to check. The very first part says that function from natural to natural, you have to be a little careful. Okay, function from natural to natural, f of x is x squared. That is the definition that is given to us. Check whether it is injective. Injective is generally 9 out of 10 cases will be okay for polynomials, but surjectivity you have to check. Like for here, so you saw surjectivity is creating trouble. So let's do injectivity. Yeah, let f of x1 be equal to f of x2. So by definition, x1 squared equal to x2 squared. Let's take the root on both sides, right? So you'll have x1 to be equal to x2. So what happened? Starting with f of x1 equal to f of x2, we are able to get that x1 equal to x2. So f is injective, right? Then we'll check for surjectivity. It is not surjective. Okay, and why it is not surjective? We know that it's enough if we give a counterexample. Now, why it is not surjective? You can just look at this function. Right. 1, 2, 3, 4, 5, and so on. So you have 1 squared 1, 2 squared will go to 4, 3 squared will go to 9, 4 squared will go to 16, 5 squared will go to 25. What if you take some number like 2? From where does it come? No pre-image, right? So that is a problem. If there is no pre-image, then you cannot have the thing to be onto. Anything like all these in-between elements, you can take any in-between elements and you can say that there is no pre-image. That is why it is not onto, right? So if you want to get, we can draw it here. Here f is as follows. We can have it formally drawn. Yeah, 1, 2, 3, 4, and so on. This is natural to natural f. So 1 will go to 1, 2 will go to 4, 3 will go to 9, 4 will go to 16, and so on. So we can write. We observe that for 2 belonging to natural numbers of the codomain, there is no natural number x such that f of x equal to 2. Right? Actually, technically, what should have come to 2? Root 2 should have come. Okay, root 2 whole squared will be 2. But then root 2 is not belonging to natural number. So, you cannot take that option. Right? So, that's why this is not. So, every time that we are given this, if it's injective or surjective, we give the proof. Otherwise, if it's not, we give a counterexample. That's about it. And there's a whole lot of problem that is lying that we're taking it up in the next video. Thank you.